Basically what's happening is I have this light that used to be battery powered and it was mounted here going up, and I have this light here as well that I would really like to have them both powered from the same 9-volt power supply, and I was in the process of dismantling and reconfiguring this circuit board when my card ran out of memory, and in deleting everything that was old that I had already moved off, I accidentally deleted my original introduction video. But here's where we are, trying to make these powered from the same power supply. Right now I'm building a new driver for this LED light. Okay, well, let's get back to it. You can see here we have, well, the light, and this was connected to the battery, but it's since fallen off. And now what I'll do is I'll take my smaller screwdriver set here. That one should do. I think I have a pretty good idea of how this circuit board is working. So, oops, thank God that didn't fall on my foot. So what I'll do is I will try to put one together really quick. So there's my custom board compared to the one that was in there. Pretty close. Fits. Now we can start stringing this together. I'll show you this project that I have. We're going to use the Arduino to control this, and maybe I'll get a tinier chip. This is actually a knockoff called the Elegoo. It's a compatible. I'm just going to take this and show you. So the way I was thinking, as opposed to using switches to control which one of these is on or off, because I mean, don't get me wrong, I do have the switches. Could use a couple of these and just, have to reach, but this thing already has a switch, and if I wanted to, I would just use that. This thing doesn't, so I'd have to make one for this. But that would just complicate the enclosure. I would have to drill more holes in the enclosure, more switches, because say I wanted more lights, I would have to drill more holes for more switches. So I'm just going to use, I got this infrared remote that I will show you here. I hope I will run the sketch. Oh, no upload port provided. So now if I hit the volume up, the fan starts to speed up. If I hit the power button, the fan turns off, and it remembers the last speed that it was on. You can turn it down, shut it off, turn it back on. Okay, so we're going to be scrapping this whole fan idea, though. So I'm just going to take all of this out. So I have this quick and dirty little setup here. I have my Arduino and a breadboard breakout on top. I have my 9-volt power supply going to the humble high side switch. So I have 2 transistors here that are going from the negative of each of these lights to the collector, the emitter to ground. The base is going to be receiving the signal from the Arduino, and I think I might already have one plugged in here. So I put these resistors here because I realized that this switch will drain the current out of the microcontroller if not limited properly. So it's going to try to send all the current through this. Put two 1K resistors just so that doesn't happen. So I've turned on my power supply. It is outputting power, and I will hook it up to this first link. And there we go. These lights are on now. Plug it into this resistor. And now both lights are on. So we just need to do this and apply it digitally so we can use some pins to control when these lights are on or off. Let's get into it. If I were to open up the serial monitor, hit something. Okay, cool. And then you can see that that's our code for our power, which I believe we already have defined. Yeah. You can figure out how to use this IR remote library. There's some instructions on the internet for that. So when we hit 1, 2, 3, so I'm gonna do 8 outputs total. So I'll make 0 stand for all. But I'm not sure if there's an easier way to do this. So we have all of our outputs now numbered. And we don't need any of this. Its current light equals 0, which means all. Lights 3 equals, well, 2, 12, 11. And then we'll do pin mode lights 0 output, pin mode lights 1 output. Just do if power digital right lights. Well, I don't need to repeat myself. Okay, so we have a pretty bare bones sketch at this point. Look at that. So we'll do bool last state equals false. Is not last state, and this should give us the option or the ability to turn this off and on. Let's go. So maybe instead of doing this, we'll just switch results dot value case power break default break. And we'll just give this really quick just for the sake of this demo. So I hacked together this little piece of code that basically takes care of each light one by one instead of just pushing out to the pins. So how it works is if we hit the power button, if the current light equals 0, we will set our lights on is equal to false. We will go through each state, and if it finds a true, it'll set the lights on equal to true, break out of the loop. So then we will use that to determine what our last state is going to be. So if the lights on is true, it'll turn this off. So it'll write off into this space in memory. And then after that, we just want to take whatever was written and push it out to that light. So there is really no difference when you're looking at it. When you press the button, there really is no difference. You can't tell. But the fact that it's still working is a plus. That means that this code is doing what it's supposed to. So now let's try to write some code to take care of this, to take care of each light. This is going to be very nasty, but let's take this, paste it here, do case 0 button, and we will set current light equal to 0. This is going to be very, very not ideal, but until I think of a better way to do this, that's how it's going to be. So 1, 2. Okay, so this is going to be if current light is equal to 0, that ends here. We'll do else last state current light -1, so that way, because this is 0, and since C++ is 0 index, this starts at 0 as well. But since we want light number 1 to be our first light button that actually controls anything, we'll have to shift that back to 0 by subtracting 1. So current light -1 equals not lasts. Well, okay, so let's do integer CLI dx for our current light index, which means current light -1. So last state current light index equals not last state current light index. Okay, and then digital write lights at current light index last state at current light index. Okay, and then we will just serial.print line current light is, and then plus the string cast of current light. And maybe I need a capital S. Sweet. So now if I press 1, current light is 1, 2, current light is 2, okay, 0, current light is 0. So if we press power here, turn them all on, and if I press current light is 1, check that out. That's pretty cool. So then we can do 2 as well. And then if we do 0, it's going to turn them all off. Then we can turn them all on. Well, that was pretty straightforward. Now I just need to do the rest of this, and we're going to actually take it a step further because I'm going to be introducing a shift register now into the equation. So here I've made this circuit board. It's a series of 8 high power switches or high side switches with a shift register that's tied to them, and I have my high power here, the 5 volts here, and we'll give it a shot. We'll see if this shift register can control my lines, which hypothetically I don't see why not. So I've painstakingly gone through and tested every single one of these connections by shifting out the binary value, and I had just one loose solder joint between the resistor and the base of my 7th output. But once I fixed that, and I also, these were too short, so the data was not sending through properly, and that was me in for a loop. But we got that all figured out. Now everything lights up. I think the last one I had was this light. So plug it in here. Yay! So what I will do now is I'm just going to kind of shove this all. Try not to short anything. There we go. So then we started shorting everything like I didn't want to do. We'll just send all ones, and both of our lights turn on. And we send 1, only that one. We send 1, 0. We get that one. We send 1, 1. We got both of them. Cool. So our shift register works. Now we just have to take all of this and bring it back to our light control. So we will delete all this, and we'll say if current light 0, do current light, and then we'll do byte. We'll call it lights. Set it to verify that. Cool. And then if lights is greater than 0, which means if any lights are on, we will set lights equal to I mean, I guess that's the same as 0, but we'll just, for the sake of being able to understand what we're doing, we're setting all of the lights off. And then otherwise you want to set the lights equal to okay, and then we will fumble. Okay. All right, let's give that a shot. So it goes through now and it turns all of the outputs on. Isn't that something? That's promising. So now what we want to do is, well, let's finish up all these cases. What function can we do to do a bitwise, like, make this the opposite? So I think I figured out a devilishly simple way to invert bits on which light is currently active. So the magic all happens in this line right here. If we take a closer look, you might ask yourself, what's that special little character right there? That is our bitwise exclusive OR operator, and defined by the MDN documentation, it's an operator that returns a 1 in each bit position for which the corresponding bits of either but not both operands are 1s. And if we go through an example here, we'll say that currently our light's byte is all zeros, which is equal to 0. Decimal, our current light is 5. And what's going on the right hand side of this operation is we're going to be taking the simple number 1 and we're going to be bit shifting it over 5 minus 1 time, or the current light minus 1 times, because we have that offset. So this will simplify to 1 bit shifted over 4 times. Okay, so now what is bit shifting? So this is the binary representation of the number 1. And bit shifting is moving the bit in which the 1 is. So now it went from 1 to 16. And when we perform our operation here, we can see that our only exclusive pair is where we had our current light set, and that will return a 1. So we'll take that back into the equation, and now we'll see our current light is 7, shifted over 6 times, and performing our bitwise exclusive OR, those are our only 2 exclusive pairs, so they both are on now. And we'll do it one more time with the number 3. It's bit shifted over twice, and we return all 3 lights that we wanted on. But now let's say we go back to 5 and send that through again. Well, we take our operands, we do our exclusive OR, and since that's our only non-exclusive pair with 1s, it will default back to 0. And I thought it was really cool. There's no if statements, no checking if a light is on. We just send that through, and this does its magic just well. And we'll go back to the main video. My circuit board burned up because I used 1K resistors, and that was nowhere near enough resistance to limit the current, but now I've got 10Ks in there. I redid some solder blobs that I saw that were just not looking good. Let's see what happens. Woo! Look at that. You can see that one too? No? There we go. And it looks like my lens is a little dirty. You thought I was gonna stop filming. So here we go to 1. We can toggle that one. And the beauty of this is that it's really just a bitwise exclusive OR. If you followed my crazy demonstration there, wherever I press my button, it will shift it over that many, do a bitwise exclusive OR, and somehow that just works. I really was not expecting it to be that easy, but hey. Okay, so this is going to seem a little redundant, but what I worked out here is that since these are responsible for delivering 9 volts at all times, I had to put a 5 volt regulator on the board for my circle light, and I also changed up the resistor values, and it seems to be giving a much better light output than the 9 volts with the 330 ohm resistor. I got the switch is hooked up right, so the bright one actually outputs bright light, and the low one outputs low light. So now I just have to put it to test in the rest of the circuit with this and the control. I found this case for an old blade razor. You can see I don't have any more razors for it, nor do I use it. So I'm just going to take this out and use this as my case. So the basic idea is that I will take my circuit board. Now there's some plastic rails on the bottom that I can use to mount it like that. And then these will go to power my lights, and through the case there's actually a hole where the wires can come out, so that's pretty cool. And I'll build another voltage regulator here for the back, and I was going to drill a hole in some plastic that was here, but it turns out that it's really just some dinky plastic. It'll all fall out anyway, so I'm gonna have to think about that. But for now, I'm going to build this display that will show me which number I'm on, and I'm just going to stick it through the front. So there's a little mock-up. I'm going to have to cut a hole in the front for the LED to fit through, but aside from that, I'm also going to do some headers, so I can kind of see if I can do this and the decoder all on one board. And the way things have been working out for me, I probably shouldn't try it, but hey, that's how we learn. So I'll get started on that, and I'll check in. So I have my number here finally all circuited up, and this is the craziest circuit board I've ever done. Let me just tell you straight off the bat. I utilized the double-sided PCB that I was just down talking, but I'll put a small screenshot on the screen of what I'm doing right now. So I'm going to do pin mode 2, output, what we'll do, hopefully if this didn't burn out because I plugged in the voltages backwards again. We'll do sweet. Hey, look at that. We got a 5. So now let me just print a 1. So something's not right there. Round 2. So plug in my light. Plug in my chip. Should get 8. Now I'm just gonna run through every single number. Goodness. That was not what we wanted. And here's the rerun. I'll slap the code I came up with on the screen now, and you can see we disabled it. Let's try that again. 0. So you just have to bit and 1 shift it over J times with I, and that will tell it which pin to write. Great, so let's move on, connecting it to the main board. Okay, it appears as though I was out of space on my computer, so I moved over some files, and now we can continue to record. And I will do display 4 because these are 4 display pins. 2, 3, 4, 5. Cool. Got that all defined. Now I will need to go here and for int I equals 0. I is less than 4, I plus plus. We just want to digital write and pin display I. We'll do 1 shifted to the right, I times bit and current light. So this should decode the binary and give us the numbers that we are looking for. So it starts off at 0. Bam. So now hopefully if I press 1, 2, 5, 6, 7, 8, this thing should happen at 9, 1, 4, 2, 5, 6, 3, 6. Awesome. That's like some of the best progress I've made. Let's turn on the power. The 9 volts. Wow. These headers are terribly loose. Okay, aside from that, if we click 1, 3, 5, 3, 7. That is good stuff, man. Go back to 0. So here's the completed circuit. I've got the Arduino mounted. It took a few hours, but I got it all worked out. I really did not have space to do that. I had no business doing this on one PCB, but well, I mean, I was gonna say it worked, but you don't know yet. I don't know yet. And I'm smiling because I'm excited to see this work, but I'm totally expecting it not to. It's showing a 0, so that's a good sign. We did it. Look at that. There it is. Now I just have to put it in the box. The lights do flash on for a second. I believe that's because of the Arduino or the Atmega. But there it is. I have light remote controlled in the dark, powered by the wall, so I never have to worry about batteries again. I only have the 2 lights for now. Now that I'm in my final setup, I don't have any of the test lights anymore. When I figure out where to put more, I will do that. And the cool thing is that this isn't specifically for lights. It just forwards 9 volts to the port. And hypothetically, if it could be powered by 9 volts, I could control it via remote so long as the power is plugged into there. I thought that was pretty cool. Do I regret going on this journey? Haven't decided yet. Was it worth it? I believe so. I got a couple more projects coming out, and yeah, until then, thanks for tuning in and going on this journey with me. Hopefully you learned a thing or two about technology used for this, and I'll catch you in the next one. Judging by how much my facial hair has grown, I'm sorry, I forgot I shaved. judging by how much my facial hair has grown, I can understand now why it takes YouTubers in this subject a long time to make videos. It takes a lot of trial and error and a lot of planning. I am sure you can tell that my video was unscripted, but I did learn a lot of new techniques to streamline the process and hopefully make it more entertaining in the future. Special thanks to my brother Alex for providing a majority of the equipment I used to do this project, and to Sky for actually giving me the kit that contained the IR receiver and the controller and various other components I actually ended up using in this project. Special shout out to Super Lo-Fi World for providing the music that I used in this video, and I will be linking the schematics and some various other project files like the sketch to my website and other various interesting links for you below. Alright, well, I'll see you in the next one.